crossing a river by a boat along a shortest path. So in the diagram, a boat starts to move from the point A, and AB is the path or the shortest path, and the boat will cross the river along the shortest path, means along AB, and D is the width of the river, and the actual motion of the river will be along AC with velocity VB or vector VB. The boat will try to travel along AC with a velocity vector VB, and water of the river will be flowing towards right with a velocity vector VW. VW is the velocity of flow of water of the river, and the actual motion of the boat will be along AC with a velocity vector VB. VB is the velocity of the boat along AC, and under the combined action of the motion of the boat and the motion of the water of the river, the boat resultant motion of the boat will be along the shortest path, that is along AB. So water will be flowing along AD, and boat will try to travel along AC with velocity VB, and the resultant motion will be along the shortest path, that is along AB. And this is the direction. That means water flows towards right with the velocity vector VW. So this is direction of flow of river water. That means river water is flowing towards right, and AB is the shortest path along which there will be resultant motion of the boat with a velocity vector VW, vector VBW. Actually, vector VBW is the resultant velocity of the boat under the combined action of the motion of the boat and the motion of the river water. Theta is the angle with which the boat will try to travel along AC with a velocity VB, and the boat starts its motion from the point A at t equal to 0 second, and the boat will reach to the opposite bank at the point B at time t equal to t second. If a boat tends to move, if a boat tends to cross the river, if a boat tends to cross a river of width d, if a boat tends to cross a river of width d along a shortest path, that is along AB. AB is the shortest path along a shortest path AB, comma, it should be row, it should be rowed. That means the boat should be rowed up, the boat should be rowed up the stream, it should be rowed up the stream at an angle theta with the shortest path AB. The boat should be rowed up the stream at an angle theta with the direction of shortest path AB. If a boat tends to cross a river of width D along a shortest path AB, it should be rowed upstream at an angle theta with the direction of shortest path AB. That means the boat tends to move along AC, and a resultant motion of the boat will be along AB, and AB is the shortest path, and it should be rowed at an angle theta with the stream, up the stream at an angle theta with the direction of shortest path. With the direction of shortest path AB, such that the resultant motion of the boat will be along the shortest path, that is along AB. Resultant motion of the boat will be such that the resultant motion of the boat will be along the shortest path, along the shortest path AB, with a resultant velocity VBW, along the shortest path AB with a resultant velocity VBW of the boat, VBW of the boat, under the combined action of the motion of the boat with velocity VB along AC and the motion of motion of flow of river water along AD with velocity VW, under the combined action of the velocity of boat VBW along AC and the motion of the river water, or velocity of river water and velocity of flow of river water under bracket vector VW along AD. Velocity of flow of water of the river under bracket vector VW. Therefore, vector VBW equal vector VB plus vector VW. That means resultant velocity vector of the boat is equal to the sum of velocity of the boat, that is vector VB, and velocity of river water, that is vector VW. Vector VBW equal vector VB plus vector VW. So this is the resultant velocity of the boat. This is the resultant velocity of the boat. Resultant velocity of the boat of velocities. Resultant velocity of the velocity of boat vector VB and velocity of water under bracket vector VW. Velocity of river water under bracket vector VW along AD. Vector VBW equal vector VB plus vector VW, which is the resultant velocity of the boat of, and in this case in the diagram, the boat will try to travel along AC with velocity vector VB, and this is what VW, velocity of river water which is flowing towards right, and along AC the boat will try to travel with velocity vector VB, and vector VBW will be along AB. That means will be along the shortest path AB. It acts along AB under bracket, that is shortest path along which it will cross the river. It acts along AB, that is along the shortest path AB. Now VBW acts at an angle phi equal 90 degree with VW. VBW vector acts at an angle phi equal 90 degree with vector VW. Means here we can draw the diagram again. This will be a parallelogram represented by two vectors, vector VB and vector VW. This is vector VW. Velocity of river water is vector VW, and vector VB is the velocity of the boat, and vector VBW is the velocity, resultant velocity of the boat with respect to river water. Now the boat will try to travel at an angle theta along AC with the direction of shortest path AB, and VBW acts at an angle phi equal 90 degree with VW. Now vector VBW perpendicular vector VW. Therefore, phi equal 90 degree. Phi equal 90 degree, which is the angle subtended by vector VBW or subtended by the resultant velocity of boat with respect to water with the velocity of water, means with the direction of vector VW. So phi equal 90 degree, which is the angle subtended by vector VBW with vector VW. Therefore, mod vector VBW is the resultant velocity equal, not the square, it should be only equal, mod vector VBW equal root over VB square plus VW square plus 2 VB VW cos theta plus phi. Angle between the two vectors, vector VBW and vector VW, is theta plus phi. That will be under square root equal root over VB square plus VW square plus 2 VB VW cos 90 degree plus theta, where phi equal to 90 degree. 90 degree plus theta, where pi equal 90 degree. Therefore, VBW, therefore, VBW equal root over VB square plus VW square minus 2 VB VW cos sin theta. VBW equal root over VB square plus VW square minus 2 VB VW sin theta. This is equation 1. Resultant velocity of the boat with respect to river water is VBW is equal to root over VB square plus VW square minus 2 VB VW sin theta. Now VBW acts at an angle phi with VW. Hence tan phi will be what? What will be the expression of tan phi? We can draw the parallelogram again. This is what VBW, vector VBW, resultant velocity of the boat with respect to water, and this is river water, velocity of river water towards right, and vector VW is a vector VB is actual velocity of the boat. VBW acts at an angle phi with VW, and VB is acting at an angle theta with the direction of VBW. In this case, phi is measured with respect to VW. That's why VW is the first vector. Phi is measured with respect to VW. That's why VW is the first vector. And the other vector, that means VB is the second vector. VB is the second vector. We know that tan phi is equal to magnitude of second vector sine angle between the two vectors divided by magnitude of first vector plus magnitude of second vector cos angle between two vectors. So mod vector VBW, that is magnitude of second vector sine angle between the two vectors. Mod vector VBW sine theta plus phi divided by mod vector VW plus mod vector VBW cos theta plus phi. Cos theta plus phi. Therefore, VB sine 90 degree plus theta divided by VW plus VB cos 90 degree plus theta. Therefore, tan phi equal. Therefore, tan phi equal VB cos theta divided by VW minus VB sin theta. In this case, cos 90 degree plus theta is equal to sin theta minus sin theta. Now tan 90 degree on the left hand side. Now tan 90 degree is infinity. We get or comma 1 by infinity doing reciprocal. 1 by infinity equal VW minus VB sin theta divided by VB cos theta, or comma 0 equal VW minus VB sin theta divided by VB cos theta, because we know that 1 by infinity is 0, or comma 0 equal VW minus VB sin theta, or comma VB sin theta equal VW, which is equation 2. VB sin theta equal VW, which is equation 2. Equation 2. Using equation 2 in equation 1. Using equation 2 in equation 1. We get VBW equal root over VB square plus VW square minus 2 VB sin theta. From equation 1 we can write VBW equal root over VB square plus VW square minus 2 VB sin theta. 2 VB sin theta. Equal root over, we can check the equation, VBW equal root over VB square plus VW square minus 2 VBW sin theta. Now putting the expression of VBW sin theta, VB sin theta, we get VB square plus VW square minus 2 VW square. Since VB sin theta equal VW, or VW equal Vb sin theta. Putting the expression of Vb sin theta in equation 1, we get Vbw equal, therefore Vbw equal root over Vb square minus Vw square. Root over square of velocity of the boat minus square of velocity of river water. And finally, we get the resultant velocity of the boat along shortest path to cross the river under the combined action of the boat and river water. And alternatively, we can prove using the property of triangle. This is a right angle triangle, and we can draw another right angle triangle, and this is vector VBW or VBW. This perpendicular is VBW, resultant velocity of boat with respect to water. And along this direction, this is what VB and VW. So another side of this triangle is VW, and this angle is 90 degree, or VBW is perpendicular to VW. So therefore, root over VB square means hypotenuse square is equal to perpendicular square plus base square. That means VB square equal to root over VB W square plus VW square. From the right angle triangle ACB, we can write root over VB square means hypotenuse square equal VBW square plus BW square means perpendicular square plus base square. So or comma VBW equal root over VB square plus root over VB square minus BW square. Therefore, the time of crossing the river time of crossing the river time of crossing the river along the shortest path AB is given by the motion of the river will be along the shortest path under the combined action of motion of the boat and the motion of the river water. The time of crossing the river along the shortest path is given by along the shortest path AB. Along the shortest path AB, you can check the diagram again. Shortest path AB is given by T equal D by VBW, distance by VBW, where D is the width of the river. We can draw the diagram again. And here we have the boat, which will have the resultant velocity VBW along this shortest path AB. AB is the shortest path along which the resultant motion of the boat will occur. VBW is the resultant velocity, and T is the width of the river. Hence, and the body starts to move from the point A at t equal to 0 second, and it will reach to the opposite bank at the point B at time t equal to t second. Hence, t equal to distance by velocity, t equal to d by vbw, d divided by root over vb square minus vw square, root over vb square minus vw square. So this is the time of crossing the river along the shortest path. We get t as equal d divided by root over vb square minus vw square. This is the time of crossing. This is the time of crossing the river, time of crossing a river by a boat along a shortest path, by a boat along the shortest path of the river. shortest path means minimum distance.